Chapter 12 begins on page 250 if you are following along in the book. We're going to talk about how to calculate different doses based on age, weight, and body surface area. So the medications that are available that are manufactured are based on the average adult. And as we know, not everyone who, lives on this earth is an average adult. So we have children, we have elderly populations, we have people who are under or over the average weight, or have certain debilitating conditions that maybe don't allow them to take a tablet, for example. So special populations need to have medications that are tailored to the dose that they need. So the reason for that is because of how drugs work in the body. So the term pharmacokinetics is basically the study of how drugs move throughout the body. So their rates of absorption, so how quickly do they enter the bloodstream, distribution, how quickly are they distributed throughout the body to the target area that is intended to be treated, metabolism, how quickly does that drug stay in the body or move through the body, and then finally excretion, how the drug leaves the body and at what time. So how long does it take to leave the body as well. Okay, so calculating medication doses by body weight. So the first rule that we're going to take a look at is known as the kilogram rule. And in the United States, we tend to use pounds as our measure of weight. So the first thing you want to do if you're ever using the kilogram rule is first convert your weight to kilograms first. So we're going to go through a couple examples here just so that we are clear with how to do those conversions. So this first weight I have here, let's say that a patient weighs 145 pounds. So if I want to change that into kilograms, well, I first have to know that 1 kilogram is equal to 2.2 pounds. Now, once I know that, I can quickly set up a ratio and proportion. So if 1 kilogram is 2.2 pounds, and I'm trying to solve for how many kilograms is 145 pounds. So remember, always keep your units equal to each other. So then we cross multiply here. So 145 equals 2.2x. To get x by itself, we just divide by 2.2 and divide by 2.2 here. So 145 divided by 2.2, that gives us 65.9 kilograms. So a little shortcut here, if you're ever going from pounds to kilograms, just take that number and divide by 2.2. Now, let's go the other way. Let's say for some reason, if we wanted to go from kilograms to pounds, well, we're still using this same conversion factor here. We know that 1 kilogram equals 2.2 pounds. So set that equal to what we're looking for. We know that we have 52.4 kilograms. This time we're looking for pounds. So we're going to take 52.4 times 2.2. That gives us 115.28 pounds. So if you're going from kilograms into pounds, you're just going to multiply by 2.2. Now it's really important that you don't confuse those two methods. So if it helps you, just set them up in a ratio and proportion so you can solve for that very quickly. Okay, so now this time I have a child who weighs 20 pounds and 3 ounces, and I want to convert this into kilograms. Well, the first thing I need to do is make sure that this entire weight is in the same unit. And we know that 1 kilogram is 2.2 pounds. So if I want to be in pounds, I need to convert these ounces into pounds first. So we also know that 1 pound is 16 ounces. So if I wanted to convert this ounces, just this part here, into pounds, just set up a ratio and proportion. 1 pound is 16 ounces. Set that equal to x over 3 ounces. So now I have 3 equals 16x. Divide by 16 to get that by itself. 3 divided by 16 gives me 0.19. I'm just going to round that. It's really 0.1875, but this will do here. So 3 ounces is 0.19 pounds. So what I just solved is I still have this 20 pounds. So I have 20 whole pounds, and then I have 0.19 pounds as well. So all I did was convert this ounces into pounds here. Now I have my unit that is all in pounds, so now I can convert into kilograms. So remember, 1 kilogram is 2.2 pounds. Set that equal to my 20.19 pounds. So I'm just taking 20.19 and I'm dividing that by 2.2. And that gives me 9.18 kilograms. Now make sure you're reading your assignment, whatever decimal they want you to round to. I just rounded to the nearest hundredth here. Okay, so if you have this handout that I gave you, we're going to first be going over the kilogram rule here. So the kilogram rule tells us that anytime we are given a dose in milligrams per kilogram, we can just take that dose times the patient's weight in kilograms, and that will give us the patient's dose in milligrams. So let's take a look at an example here in the book. I am on page 245 in the pretest, looking at number 12. So first we see a child weighs 83 pounds. The physician orders Biaxin oral suspension 10 milligrams per kilogram, BID, or twice a day. In stock, we have clarithromycin 125 milligrams per 5 ml when reconstituted. So we can see that we have a liquid oral suspension here. It says, what volume of medication should be given per dose? Well, first of all, my weight is in pounds. I see that right off the bat. My dose is given in milligrams per kilogram. So the first thing we need to do here is turn that 83 pounds into kilograms. So 83 pounds, we can set that equal to 1 pound. Oh, sorry, 2.2 pounds. Here, I'll rewrite this over here. So we have 1 kilogram is 2.2 pounds. Set that equal to my 83 pounds. Now we can solve for x. So 1 times 83 is 83. And then we have 2.2x. So divide by 2.2 here. So 83 divided by 2.2, that gives me 37.73 kilograms. So I'm going to transfer that over here. So I know that their weight now is 37.73 kilograms. Now, if you remember the kilogram rule that I just showed you, it tells us to take the dose in milligrams per kilogram times the patient's weight in kilograms, and that will give us their dose in milligrams. So if we take 10 milligrams per kilogram times 37.73 kilograms, well, that is always by itself, so it's just over 1. So you can see that these kilograms cancel out, and we're going to be left with just the milligram dose. So 37.73 times 10 would be 377.3 milligrams. So in this case, since we're at the milligram here, I would just round to the nearest milligram. So 377 milligrams. But remember, milligrams is a weight. So this is my dose weight. The question is asking for the volume per dose. So we're looking for the dose volume. So remember, for dose volume, we can always set the dose weight, or the order, equal to the stock strength that we have here. So we know that we need 377 milligrams twice a day. So we're going to take 125 milligrams per 5 mil, because that's what we have in stock. Set that equal to my dose, which is 377 milligrams. And solving for x will give me my dose volume. So that gives me 125x, and then we're going to take 377 times 5, which gives me 1,885. Now to get x by itself, I divide by 125. Do the same thing here. And then x is 15, and if I'm rounding to the nearest tenth, 15.1 milliliters. Okay, the next question says, what's the measurable volume of medication in each of the following systems? So the metric and the household. Well, they give us two dosage administration devices here. So you can see that the 20 ml syringe, each hash mark between the 15 and the 20 would be 1 milliliter. So 15, 16, 17, 18, 19, 20. So there's no way for me to accurately measure out 15.1 milliliters using this syringe. So I would just have to round that to 15 milliliters. Now here, if we're using household measurements, well, 15 mils is here, which is roughly equal to 1 tablespoon. So when you're looking at the measurable volume, make sure it's something that you can actually measure in your measuring device. Okay, now I am on number 15 on page 248 of the pretest. So the question says, a 45-pound child is prescribed Lorabid 15 milligrams per kilogram per day in divided doses twice a day. So this time they're giving us how much they need per day. And we know that each dose is given twice a day. So that is important. We'll come back to that. What is the strength per dose for the child using the label shown? So here we have the label here. The strength we see is 200 milligrams per 5 milliliters. So that is my strength of the drug. I know that the order is for 15 milligrams per kilogram per day, and that we have a 45-pound child. So right off the bat, when I see my weight in pounds, I want to convert that into kilograms. So remember, 1 kilogram is 2.2 pounds. So I can set that up equal to my weight here. So essentially, I'm taking 45 divided by 2.2. So X is 20.45 kilograms. So now that I have my my weight in kilograms, I can use the kilogram rule. So remember, this is milligrams per kilogram per day. So if I want to do this per dose, I see that they're taking 2 doses a day. So I need to divide this 15 by 2. So 15 divided by 2 would be 7.5 milligrams per kilogram per dose. Because remember, we're looking for the strength per dose. Now that I have that, now I can take 7.5 milligram per kilogram times my 20.45 kilogram. And if it helps you, put that over 1 so you can visually see that these kilograms are canceling out. So I'm taking 7.5 times 20.45, which gives me 153.4 milligrams. So roughly 153 milligrams here. Now says, what is the measurable volume per dose of medication? Well, if we're looking for the dose volume, remember we always set our strength. So I know my drug has 200 milligrams in every 5 mils. I set that equal to what's being ordered. So they need 153 milligrams, and then we can solve for X. So 200 times X, and then we have 5 times 153, which gives me 765. Divide by 200 on both sides. So X, I got 3.8 milliliters. So if you look at your 5 ml syringe, which we'll take a look at these syringes in class this week, we can actually measure to the nearest tenth with a 5 ml syringe. So that would be my measurable dose. When I entered this in my calculator, it came out to 3.825. Well, rounding to the nearest tenth would be my measurable dose. Now it says, what is the total dosage of loracarbef in milligrams per day? So remember, the dose that they wanted was 153 milligrams per dose, but they want the dosage per day. So remember, they're taking this twice a day. So if you're taking 153 milligrams 2 times per day, well, 153 times 2 would give us 306 milligrams here. Okay, so if you couldn't see what I was doing there, we took 153 milligrams per dose, and they were taking that 2 times a day. So 153 milligrams times 2 gives me 306 milligrams. Now I'm going to take this a little bit further. I know they don't ask us to find the volume per day, but if we needed to, remember they need 3.8 mils per dose. And if they're taking that 2 times per day, we would just multiply that by 2 to find the dose volume that they need per day. So make sure that you really read these questions carefully. If it's asking you for milligrams or if it's asking you for milliliters, remember volume, milliliters is the unit that we use for that. Weight, we use milligrams if they're asking for weight.